Hi there, this is a quick supplemental video for Chem S-17, section number 1, and the topic of this is nomenclature. So I made a little table here that kind of summarizes a bunch of the kind of basic nomenclature things that will be the most important to you going forward. There were obviously more in lecture, but these are the kind of biggest ones. So first, let's start off with calling something an R group. R here can be used just to abbreviate anything that we want, basically. And it's especially helpful with, like, let's say you're doing some sort of reaction and you want to react with this alkene over here, and you have all this other nonsense on the end that we don't want to react with. Like, this is just kind of a weird example. But let's say I don't care about any of this. None of that's going to do any reaction. And so to save me some time, I could just write this whole thing as R. And then it would be helpful at some point to write out that your R was going to be equal to that thing that you abbreviated it as. And so this is going to be a lot more compact way to write things. And it also helps us kind of generalize reactions by calling something R. And so if R is not specified like it was in that example, R is just assumed to be any alkyl group. So for example, ROH as an alcohol, that could be CH3OH. It could be like ethanol, a CH2 and CH3, or any other like alcohol possible. All of those fall under the umbrella of ROH. So that's R as an abbreviation. Then we have a couple of naming things that are associated with benzene rings. So if we have a benzene ring as a substituent, we call it a phenyl group with a PHENYL. And you'll notice that the names of these molecules as substituents, they will have a YL ending if it's a substituent. If you'll remember like methane from lecture, ane is when you're talking about the like parent chain or the exact molecule, whereas YL is it's something that's hanging off of a bigger thing. So this is also tedious to write, so we have an abbreviation. We just can write PH to abbreviate the phenyl. Similarly, if we have a benzene ring and one extra carbon, this is given a special name called a benzyl group. And we can abbreviate it with a BN. So here's an example of a molecule here that has a phenyl over here, and then a benzyl because it has this extra CH2 over here. And another way that we could write it here is with the PH and BN abbreviations. So we have a similar thing going on over here with just alkyl substituents here. Remember, the ones that have weird names for organic chemistry are the 1, 2, and 3, 4 carbons. And so the way I kind of do it, this is like not like scientific, it's just the way I remembered it from when I did OChem 1 for the first time. I would go meth, eth, prop, bute. Meth, eth, prot, bute. Actually, I think I just said prot instead of prop, but I mean prop. Just to kind of ingrain that in, that meth is 1 carbon, eth is 2 carbons, prop is 3, and bute is 4. And then the YL for all of them just says that it's a substituent. So we could write out all of these like in this kind of condensed form here with all the H's written and everything. The nicer way is skeletal structures, but also just like for the benzyl and phenyl, how we have these abbreviations here just with like some letters, we have special letter abbreviations for these as well. So for methyl, it's ME, for ethyl, it's ET, for propyl, it's PR, and for butyl, it's BU. So when we say propyl, we are typically just saying that we have 3 carbons hanging off. But we could attach those 3 carbons in a straight chain like this, or we could attach it from that middle carbon. When we attach it from the middle carbon, it's called isopropyl. And you'll probably remember that Tim from lecture has the little mnemonic of Y, so propyl. And I imagine it in the kind of Batman voice of, why so serious? Why so propyl? And iso just is because that this is an isomer of the other one. The other one's technically called N-propyl, but if you leave off the N, everyone will know what you mean. It's assumed if it doesn't have a prefix or anything in front of it, that it will just be propyl. Also, isopropyl has a cute little thing for the abbreviation here where it has a superscript I above it and then a PR. Boop. So that's methyl, ethyl, and propyl. And then butyl, we have the N-butyl, and I don't know if I said it already, but N there stands for like normal, which we just mean like a straight chain. But we have various other ways that we could attach 4 carbons as like something hanging off of a chain. So instead of attaching it here, we could kind of move one of our carbons and like pluck it over here to where we have the Y again. And then in that case, we call it isobutyl with the IBU abbreviation. The one that looks like a chicken foot is called tert-butyl. And I don't know, I think about like a turkey, like a turkey foot, and that's how I remember it. But really, it comes from the word tertiary. And it's because we have 1, 2, 3 things off of this carbon that's attached to the main chain. So again, we're talking about this group here together. It has 4 carbons, so it's in the butyl family. And because there are 3 things off of it, we would say it's tert-butyl. Similarly, over here, this carbon that's off, where we have 4 carbons in this little group, we have 2 different branches off of that one that's attached to the main chain. And so it's secondary or sec-butyl. And that's pretty much it with these kind of common abbreviations. So IUPAC naming. Basically, chemists throughout history were just calling molecules their own thing, and they had their own systems. And then someone was like, guys, this is crazy. We're calling the same molecule like 5 different things. We need to get on the same page. We need to make sure everyone's with the program. And so this like society, IUPAC, which I think is like International Union of Pure and Applied Chemistry, something like that. They said, here are the rules. Here is the like scientific name for how to name any compound. They have a lot of rules, like it's a big manual, like almost like an MLA manual or something that can cover every circumstance of how to name a molecule, and it gets really complicated. And other classes do a lot more naming. For our class, for Chem S-17, we're only going to do pretty basic naming. We're mostly going to do naming alkanes. Maybe later we'll do some naming of alkenes, and maybe some simple other like substituents, but it won't be like nearly as intense as many other organic chemistry classes. So for our purposes, the 3 biggest things that we need to consider are 1, we need to find the longest continuous chain of carbons, and that is what we're going to call our parent chain. 2, we have to figure out which way to number the carbons on our parent chain. Typically, we can imagine it being like left to right or right to left. And we want to number it in a way that minimizes the numbers on the substituents. So for example, if numbering it one way had substituents on like 2, 3, and 5, and the other way it was on 2, 4, and 5, then the one that we would favor is this one, because they both start with 2, and then the next one is 3 versus 4, and 3 is lower. So we would want to number it this way for our numbering of our substituents rather than the other way. And then the last thing is, once we have done this identification of our parent chain, we've done our numbering, and we've identified like what all the kind of substituents and things hanging off the parent chain are, then when we go to actually name the compound, the big thing that we have to do is we have to put the substituents that we have kind of listed out in alphabetical order. And we indicate what carbon on the parent chain it's attached to, the number, with a locator. And it would look like 2-methyl. So let's say you had a compound that had a methyl on 2 and it had a ethyl on 5. When we go to name the actual compound, the way that we would put these in order is we would do 5-ethyl, 2-methyl. And then we would say like our parent chain name. So this is what we mean by ABC order of E goes before M here. Now, note, it does not matter about the numbers going from lowest to highest. It's all about ABC order of the substituent. Now, another kind of thing here that's a little bit weird, a kind of tricky rule, is let's say you had 2 methyls. Let's say you had 2 and 3 methyls. We would add this prefix di-methyl. So if you had 3 methyls, you would say trimethyl. 4, you would say tetramethyl. Yeah, that's the right one. So what do we do with ABC order for this? Do we pay attention to this di, which is at the very beginning, or do we pay attention to the M for methyl? And for these prefixes of di, tri, tetra, we pay attention to what the actual substituent is, so methyl. So we would ignore the D here, and we would keep this as M. And so if we had another substituent like 5-ethyl, that would go before these methyls here. One other further really confusing thing is for prefixes like iso, like isopropyl. For isopropyl, you would include the I in the ABC order, and it would not be the P. And so, for example, it would be like 3-ethyl, 4-isopropyl, 5-methyl. And here it would be the I is coming before the M. Whereas like if it was just a propyl and not isopropyl, the P would be after M. LMNOP. Yes, that's right. Cool. So these are the kind of 3 basic rules that you need to start kind of moving, grooving with some basic naming. And with that, let's try to jump through a practice. So this is going to be Skill Builder Lecture 1, page 14 in the problem set. And they are saying that they're going to give us an incorrect name for an alkane. And then use that name, we are going to draw a skeletal structure. And then we're going to correctly name it and say why their name is incorrect. So let's start with this example. So the first thing to look at is the parent chain. And it's going to be a pentane here based on what they've said. So we're going to draw 1, 2, 3, 4, 5 carbons. We have our pentane backbone. So now, when they've given you a name, you don't have to decide which way to like start in numbering. Like either way, you're going to get the thing that they want you to get. So I'm just going to start numbering 1, 2, 3, 4, 5 like this. You could do it the other way, and it would be totally fine in this case. And then on 2, I'm going to put an isopropyl. And on 3, I'm going to put a methyl. So this is the structure that we need to now kind of correctly name and figure out why it's wrong. So let's try step 1 and figure out what's the longest chain. Well, in this names version, the longest chain is this, 5 carbons. But actually, we can make a, what is that, 6 carbon chain, right? 1, 2, 3, 4, 5, 6. So our parent chain is going to be this. Even though it's not kind of completely like zigzag linear, that doesn't matter. It's a continuous chain of carbons. So we know that we are going to have a hexane. And right now I haven't done the official name yet. I'm just going to list some things over here. So now, if we look at our hexane, I'm going to try to start numbering this correctly. And so, just so these other numbers don't distract us, I'm going to do a little copy and paste and move this over. Okay, so we need to figure out if we should number 1, 2, 3, 4, 5, 6 like this. And I think I'll use some color here. So I'm going to do 1, 2, 3, 4, 5, 6. And if we did it that way, our substituents would be on 2, 3, and 4. Versus if we did it this other way, and we did 1, 2, 3, 4, 5, 6. This way, our substituents are going to be on 3, 4, and 5. So now we look at which way lowers the number on our substituents. And here, having our first substituent on 2 is going to be better than having our first substituent on 3. So we don't use this numbering, we do use this numbering. And our substituents for each of these are methyls. So when we have more than one methyl, we have to use that prefix. So here, the prefix for 3 of the methyls would be trimethyl. So it would be 2, 3, 4, trimethyl. So the new name, and maybe I should say the correct name, is 2, 3, 4, trimethyl hexane. Boop. And the reason why it was wrong was wrong parent chain. Let's do one more, same exercise. So for this one, I'm going to start off drawing the backbone that they give us, pentane 1, 2, 3, 4, 5. Then I'm going to start adding substituents. For my basic numbering, I'm going to do 1, 2, 3, 4, 5 like this. And again, I could do it the other way. It doesn't matter when they give you a name. It only matters when we try to make the new name. So on 2, I put a methyl. On 5, I put a tert-butyl. So that's 1, 2, 3, 4 carbons, and it's little chicken foot. I think a lot of people, a common mistake would be people just doing bump, bump, here. But here, you've only added 1, 2, 3 carbons. This carbon was already there. So you have to add one more. So 5 tert-butyl, 2 methyl, and that's it. Okay. So yet again, we have a parent chain issue. When we look at it this way, our parent chain isn't just this 1, 2, 3, 4, 5. Ooh, 1, 2, 3, 4, 5. It's also 6, 7. So we have a heptane. And again, our issue is wrong parent chain. Okay, so then if we look at our substituents this time, we should try numbering. So I'll do the same thing I did in the last example, where I'll copy this over, just so that the old numbering doesn't mess us up. And option green is going to be 1, 2, 3, 4, 5, 6, 7. And option light blue is going to be 1, 2, 3, 4, 5, 6, 7. So our substituents in the light blue are on 2, another one on 2, and we would have to list out both of these on 2 to make sure they know that each one of those methyls are on 2. We couldn't just use one of the 2's. And then 6, that would be the kind of light blue numbering system where everything would land. And then for the green numbering system, we would have substituents on 2, 6, 6. So this light blue wins. Again, we have 3 methyls. They're all the same substituent. So we would do 2, 2, 6, trimethyl. And then we would put our parent name, our heptane. And there, we've done it. So both of these, we didn't really have to deal with the ABC order because we had all the same substituent. But once we start getting a little bit more complicated, I think in one of the challenge problems you'll see, you'll have to then do a step where you put things in ABC order. So I like an intermediate step of like listing out the parent chain and the substituents, and like let's say you had another one like a 5-ethyl or something like that. Then this is your kind of scratch workspace, and then when you write your actual name as like the answer, you can put it in ABC order then. That's all I have for you. Hopefully this wasn't too terribly long. But yes, let me know if you have any questions. Goodbye.